In this video, we are going to be learning about how to read solubility charts. For your textbook, you can refer to Chapter 14, Section 3. So the first thing we need to do is we need to know some definitions. So you need to know what solubility means. Solubility is the maximum amount of solute that will dissolve in a certain amount of solvent. So we also need to know what these two words of solute and solvent mean as well. So the solute is the substance dissolved. So if you were dissolving some salt into water, the salt would be the solute, and then the solvent would be the water. So that's the material that does the dissolving. So solubility is the maximum amount of salt that you can dissolve at that particular temperature in the water. So with that given definition, that means that temperature is going to affect how much of the material can be dissolved by the solvent. So temperature is going to affect it. Now, it does not always mean that increasing the temperature is going to increase the solubility. Gases, it is a bit different, and there are some certain compounds where increasing the temperature does not increase the solubility. So what we have are some curves where that data and information is plotted, and we're going to look at those solubility curves and analyze them in order to figure out if the material is what we call saturated, unsaturated, or supersaturated. So that's the next thing we're going to define. So our three different kinds of solutions include saturated, unsaturated, and supersaturated. So saturated means that it is holding exactly the amount that it can, the maximum that it can at that particular temperature. Supersaturated means that it's actually containing more than it should hold. And so it's what we use in order to create things like rock candy. And then unsaturated means that it's containing less than the solute could hold at that particular temperature. So the next thing we have to learn is how to read these solubility graphs. It's pretty simple. First, find the material that you want to know about its solubility. So let's say we're looking at hydrochloric acid. I would be looking at this line right here. And what these lines actually tell us then is they tell us at what temperature how much all of the material will be able to dissolve. So let's say that I have liquid at 20 degrees and I want to know how much hydrochloric acid I can dissolve at that temperature. I would go up and I would see that it's just over 70 grams in every 100 grams of water. So I'd need 100 milliliters of water and I would be able to dissolve just a little bit more than 70 grams of hydrochloric acid in that. So here's another example for you. I might ask you a question such as this one here. How much KNO3 potassium nitrate dissolves in 100 grams of water at 50 degrees Celsius? Well, the graph itself already tells us that it's in 100 grams of water, so I don't have to worry about anything there. So all I need to do is find the line for the material, which is going to be this one right here, the red line, and then go to the temperature that I am interested in. So I want to know about 50 degrees. So I go up to the line, and then I would go across to see how many grams would be able to dissolve. And so it ends up being about 87 grams will dissolve at that particular temperature if I have 100 milliliters or 100 grams of water. Let's talk next about those words saturated, supersaturated, and unsaturated. So when we are on the line, that tells us that the material is saturated. If I'm holding more material than it can at that particular temperature, then the solubility is at a supersaturated ranking. And if I'm underneath it, then that means I can fit more, so I'm unsaturated. So if I were to give you the example of, let's say that in 30-degree water, I have dissolved 80 grams of sodium nitrate. Well, you can see I'm below the line. So that means that my material is unsaturated. If at 30 degrees I got 120 grams in there, then I would be supersaturated. So this is going to involve some math, and you have to make sure that you know which material is the solute and which material is the solvent. So again, recapping those vocabulary words, you want to make sure that you understand that the amount of solute is the material that is being dissolved. So if I was making salt water, my solute would be the salt, the NaCl, and then my solvent is the water, the material that's doing the dissolving. So our equation is going to look like the one given here. If I give you a certain solubility and I have an unknown solubility, I simply put the amount of solute divided by the amount of solvent equal to my unknown amount of solute over the amount of solvent. Here's your first example. It says the solubility of a solid is 15 grams in 100 grams of water. How many grams of the solid must be dissolved in 1 kilogram of water in order to make the solution saturated? So first thing you have to remember is that a kilogram of water would be 1,000 grams. So you do have to do a little bit of a conversion there. Kilo is 1,000. Go ahead and pause the video. See if based on the equation I gave you in the previous slide, you can work this out on your own, and then I'll show you what your work should look like. So here's what your math work should have looked like. Again, I give you that the amount of solute is 15 grams that can fit in 100 grams of water. And I'm going to set that equal to our unknown. So I don't know how many grams I could fit if I had 1,000 grams of water. And then I simply just solve for my x. So this is where some of our algebra background comes into place. You can cross multiply 100 times x is equal to 1,000 times 15, and then you solve for x, which you would get 150 grams. Go ahead and try another example on your own. This one says that if you have 50 grams in 500 grams of water, using the same solubility from problem 1, is the solution saturated? So remember, first you need to figure out how much can you fit, and then compare that to the 50 grams that you have in 500 grams of water. See if you can set it up, pause the video, and then come back and see if you got the right answer. So here is what your work should have looked like. You should have taken the original solubility of 15 grams over 100 grams, set it equal to trying to figure out, well, how much could you fit in 500 grams? And when you solve for the x, you would get that 75 grams would be saturated, but you only have 50 grams in your solution. So that means that you are not saturated. You are unsaturated. You would need 25 more grams in order for your 500 gram water solution to be saturated. Let's try another example. This one tells you that the solubility is 5 grams for every 100 grams of water at 20 degrees, and that at 50 degrees Celsius, there's 7.5 grams that can dissolve. So it wants to know how much of the solute must be dissolved in 250 grams of water at 20 degrees Celsius. So be careful. This problem is trying to trick you a little bit by giving you an extra piece of information that you really don't need. At this point, you don't need this piece of information right here because it's specifically asking you for at 20 degrees Celsius. So if I set this up, I would have 5 grams would fit in 100 grams of water, and I would set that equal to wanting to know how many grams I can dissolve in 250 grams of water. So go ahead, set that up, solve for x, and see if you got the right answer. So when you solve for x, you should have gotten 12.5 grams would be needed to make a saturated solution at a temperature of 20 degrees Celsius. This problem has two parts to it. So it says that the solubility of a solute is 5 grams will fit into 100 grams of water at 20 degrees Celsius. And at 50 degrees Celsius, 7.5 grams are going to fit into that 100 grams of water. So it says if a saturated solution is prepared using 200 grams of water at 50 degrees Celsius, will it still be saturated if it cools down? So the problem with this question is that we first need to figure out, well, how many grams are going to go in if I'm doing 200 grams of water at 50 degrees Celsius. So there's two parts to this. I first need to use this piece of information here and set that equal to x over 200 grams and solve for x. So that'll tell me how many grams I'm going to need. And then I have to use this piece of the problem to solve for x over 200 to see how much will precipitate out. So see if you can set up this piece first. I'll go over that piece, and then I'll go over the second step after that. So here's the first step. We first need to find out if it will be saturated at 50 degrees Celsius. So I had said we need to use how much do we need at 50 degrees Celsius to be saturated. So this is your given solubility, and you set that equal to x over 200 because we need to know how many grams are needed to make that solution in 200 grams of water. So I need 15 grams of that material, of that solute, to put into 200 grams of solvent. So will it be saturated is the next step. So on the next step, will it still be saturated? So we figured out that we needed to put in 15 grams at that particular temperature. So now at 20 degrees Celsius, here's the key. At 20 degrees Celsius, we can only fit 5 grams for every 100 grams of water. So that means that if I've got 200 grams of my solvent, I can fit 10 grams of that solution in. But if you remember from the previous slide, we put 15 grams in at that other temperature. So now we compare. At the other temperature, I put 15 grams in. But if I cool it off, I can only fit 10 grams. So will I still be saturated? Yes, I'm actually going to be super saturated because that solution is holding 15 grams, which is more than the 10 grams that it can hold at that temperature. Now let's consider another thought. How much will precipitate out? We've seen this word precipitate before when we looked at some different chemical reactions. A precipitate is a solid that forms. And so because we're not going to be able to fit as much of the solute in at that lower temperature, some of the material is going to solidify and precipitate out. So it's going to be a solid that actually forms. And this is how they make rock candy. And so at the 20 degrees, we had this rate of solubility. 5 grams could fit into 100 grams of water. And at 50 degrees Celsius, we could fit 7.5 grams into 100 grams of water. So we figured that if I have 200 grams of water, we would be able to fit 10 grams. And at the higher temperature, we would be able to fit 15 grams. So now all we have to do is look at the difference between those two amounts. And the difference between the two, 5 grams, will precipitate out. Let's do an example of another problem. This one says how much less sodium chloride or potassium chloride, KCl, is dissolved at 20 degrees Celsius than at 60 degrees Celsius in 100 grams of water. So the nice thing is that it is asking us for 100 grams of water, and you can see right here in our values that it is already, the graph is telling us how much will fit in 100 grams of water. So we don't have to do too much math. All we have to do is subtract the two values. So I highlighted the red line here. all you have to do is look at how much is going to dissolve at 20 degrees, which is going to be right here, and how much is going to dissolve at 60 degrees, which is right here. Subtract those two differences. So we've got 45 minus 32, and that would mean that 13 grams less is going to dissolve. The next problem asks me for something a little bit different. It asks me how much more KCl potassium chloride is required to saturate the solution if 25 grams are dissolved at 40 degrees Celsius. So I'm going to look at my 40 degrees Celsius right here. I'm going to go up from 40 degrees to my KCl line, and I'm going to see that at that point, I am going to need about 40 grams, but I only have 25. So the question wants to know how much more am I going to need. So 40 minus the 25 that I have means that I need 15 more grams in order to saturate my solution. So I have a few more example problems for you. You're going to need to use the graph on the previous slide, so you can go back to that, or one of the ones on some of the worksheets from class. I can also post one online. So there are 5 problems here. Go ahead and try them on your own using the graph. I've also marked for you what the compounds are, what their formulas are, so that you're not trying to figure that out. So potassium chlorate and potassium iodide, they are there for you. Pause the video, try and figure them out. I will post an answer key online for you for these 5 problems, as well as some additional ones on the next slides. So here are a few more problems for you to practice. Pause the video at this point. These will also be on a key posted on Schoology. After you're done practicing them, you can see if you got them correct or not. And then 3 more for you to try. Again, I will post the answer key. These problems get a little bit tougher, so as we're working through this unit, I would come back and try these as well to prep for your test. I will also have the answer key on Schoology. And finally, these are the hardest types of problems that you will see. Again, practicing these throughout the unit, coming back and checking the answer key on Schoology is going to be very useful with all of these.